Imagine for a moment, a team of modern scientists, hunched over a pile of yellowed, fragile documents, their faces illuminated by the soft glow of computer screens and lab equipment. They're not just reading history, they're about to change it. What if, hidden in the chaos of World War II, there was a secret so powerful, so revolutionary that it could transform the way we power our world? Today that secret is being unearthed, and it might just be the key to unlocking clean, limitless fusion energy, a dream that has eluded humanity for nearly a century. This is the story of how a forgotten experiment from 1938 could rewrite the very foundations of science and energy as we know it. Let's travel back to 1938. The world was on the brink of war, and in a quiet laboratory in Germany, two scientists, Otto Hahn and Fritz Strassmann, were about to make history. Their lab was filled with the clatter of glassware, the hum of primitive equipment, and the quiet intensity of minds on the verge of discovery. Hahn and Strassmann were pioneers, driven by curiosity and a relentless desire to understand the building blocks of the universe. They were experimenting with uranium, a heavy, mysterious element that had captured the imagination of physicists everywhere. Their goal? To see what would happen if they bombarded uranium atoms with neutrons. At the time, the prevailing theory was that this might cause the atoms to fuse together, creating even heavier elements, a process known as nuclear fusion, which powers the sun and stars. But what happened next was completely unexpected. Instead of fusing, the uranium atoms split apart in a violent reaction. This was nuclear fission, not fusion. The atom, once thought to be indivisible, was shattered, releasing an enormous amount of energy. This discovery would change the course of history, leading to the development of nuclear power and, tragically, nuclear weapons. The world would never be the same. The nuclear age had begun, and the focus of science shifted almost overnight. Fission became the buzzword, and the promise of fusion, the idea of harnessing the same power that fuels the stars, was pushed to the background, overshadowed by the immediate, world-altering implications of fission. But here's where the story takes a fascinating turn. Buried deep in the handwritten notes and dusty records of Hahn and Strassmann's experiments was a curious detail. An experiment involving lighter elements, not uranium. It was a footnote, a side project, almost an afterthought. But to a careful reader, it hinted at something extraordinary. A different kind of fusion, one that didn't require the extreme temperatures and pressures of the sun. For decades, this experiment was overlooked, lost in the shadows of history. The world was too busy racing toward fission to notice the quiet clue that might have pointed to a new path for fusion. Time marched on. The decades rolled by, and the world changed. Laboratories became more sophisticated, computers replaced slide rules, and the dream of fusion power remained just out of reach. Scientists built massive machines, tokamaks, lasers, and magnetic confinement devices, trying to recreate the conditions at the heart of the sun. Billions of dollars were spent, and progress was made, but the holy grail of practical, clean fusion energy remained elusive. The old records from 1938 gathered dust, their secrets waiting patiently for someone to look again. Fast forward to today. In a state-of-the-art laboratory at the University of Wisconsin, a new generation of scientists is taking a fresh look at the past. Armed with cutting-edge technology, artificial intelligence, and a relentless curiosity, they've decided to recreate the forgotten experiment from 1938. This isn't just a simple replication, they're using tools and techniques that Hahn and Strassmann could only have dreamed of. High-precision sensors, advanced data analysis, and AI-driven modeling allow them to probe the mysteries of atomic interactions with unprecedented detail. The air in the lab crackles with excitement as the team prepares to run the experiment, knowing that they might be on the verge of a discovery that could change everything. The experiment begins. Neutrons are fired at lighter elements, and the data starts to flow. At first, everything seems normal, until the energy readings spike. The scientists stare at the monitors in disbelief. The output doesn't match any known fission reaction, and it's not the kind of fusion they've seen before. It's something new, something unexpected. The energy is there, unmistakable and measurable, but it's being produced without the extreme heat and pressure that have always been considered essential for fusion. The team double-checks their equipment, reruns the experiment, and the results are the same. They're witnessing a phenomenon that defies conventional understanding, a potential breakthrough that could rewrite the rules of nuclear physics. If these results hold up under scrutiny, the implications are staggering. Imagine a world where fusion energy can be achieved without the need for massive, expensive reactors or the risk of runaway reactions. Clean, safe, and virtually limitless energy could become a reality, powering cities, industries, and homes without the pollution and dangers of fossil fuels or traditional nuclear power. The dream of harnessing the power of the stars could finally be within reach, not in some distant future, but in our lifetimes. The scientists in the lab are acutely aware of the stakes. They know that their discovery could spark a new era of innovation, transforming everything from transportation to manufacturing to the way we live our daily lives. To put it in perspective, it's like stumbling across an old, forgotten blueprint in your attic, one that, if understood and applied, could lead to the creation of the next generation of supercars. The blueprint is old, but the ideas within it are timeless, waiting for the right moment and the right minds to bring them to life. That's what's happening in the world of fusion research right now. The past is speaking to the present, offering clues and inspiration that could unlock the future. The excitement is palpable, not just in the lab, but across the global scientific community. Researchers everywhere are dusting off old records, re-examining forgotten experiments, and asking new questions about what's possible. Suddenly, the world is paying attention. International teams of scientists are collaborating, startups are racing to develop new technologies, and governments are investing in research at unprecedented levels. The possibility of a new path to fusion energy has ignited a wave of innovation and competition. Conferences are buzzing with excitement, and the race is on to see who can turn this breakthrough into a practical, scalable solution. The stakes couldn't be higher. The world's energy needs are growing, and the challenges of climate change demand bold, transformative solutions. Fusion energy, once a distant dream, is now within sight, and everyone wants to be part of the revolution. The question on everyone's mind is simple, but profound. Could this forgotten fusion experiment rewrite everything we know about powering the planet? The implications go far beyond the laboratory. If this new form of fusion can be harnessed, it could provide clean, abundant energy to every corner of the globe. Imagine a world where energy is no longer a source of conflict or pollution, but a force for progress and prosperity. Cities could be powered by fusion reactors the size of shipping containers. Remote villages could have access to reliable electricity for the first time. The possibilities are as vast as the imagination itself. Of course, science demands rigor. The experiment is now under intense review. Teams of independent researchers are poring over the data, replicating the results, and searching for any possible errors or alternative explanations. Peer review is the crucible in which scientific truth is forged, and only time will tell if this discovery stands up to scrutiny. But even at this early stage, the implications are massive. The mere possibility of a new path to fusion has already changed the conversation, inspiring a new generation of scientists to dream bigger and reach further than ever before. In a sense, the past is shaking hands with the future. The work of Hahn and Strassmann, nearly forgotten in the rush of history, is now inspiring breakthroughs that could shape the world for generations to come. It's a powerful reminder that science is a journey, not a destination. A story that unfolds across decades and centuries, with each generation building on the discoveries of those who came before. The laboratory benches of 1938 and the high-tech labs of today are connected by a thread of curiosity, ingenuity, and hope. The story of fusion is far from over. In fact, it's just getting started. So, if you're as fascinated by this unfolding story as we are, make sure to hit like, subscribe, and stay tuned. We'll be following every twist and turn as scientists race to unlock the secrets of fusion and build a brighter, cleaner future for us all. The next chapter in the story of energy is being written right now, and you won't want to miss a single moment.